Good evening, friends. Welcome to Eastern Academy. We are into embedded system programming. As a part of that, we are discussing digital electronics, session 4. And last few sessions, we discussed about logic gates, combination logic, and application of combination logic. And in this session, we are going to discuss about sequential logic. That's another most important one in the discussion. And this is the second one. The three of them: sequential, combinational, sequential, and tri-state. The three, once you understand, you can be able to understand any of the digital circuits. Only three. You'll be very surprised. The whole digital world, built with only three: combination logic, sequential logic, tri-state logic. You'll be very surprised. Okay. And these three are built using three: and, or, and not. And these three are building with a switch. That's all. See, what is simple. You don't have to remember. You don't. This even a fifth or sixth standard student can listen. You don't have to be an engineer for learning these things. This has to be taught in the schools itself. Now, let me draw a diagram. Try to understand this. I have an AND gate, and I have a NOT gate. I have two inputs. Please understand. I have two input. If an input is 0, you know the AND gate, one input is 0, output is 0. So this become 1. Am I right? If the input is 0, output is 1. That is right. But if the input is 1, if this is X means 0 or 1. That's all we call don't care. Understand? Now, what is this? This is also X, because when you don't know this, you don't know this, because it's 1. 1, 0 is 0, 1, 1 is 1. You know, what is this? Can you tell me? People always say X bar. No, this is also X. X means don't care. X means don't care. When I say don't care, what is a don't care bar? That's also called don't care. Please understand. Don't get confused between don't care and don't care bar. This is also X. Okay. This is also X. This is not X bar. This is X. Now, see here, I draw one more logic here. I have one more logic. Life is very simple. Same copy. Okay, this is all fine. I do only one small thing here. What is a small thing? This is called Q. Sorry, this is called Y. This is called A. This is called B. Now these two inputs, let us call M and N. Let us call M and N. This one, I call it as a Z. Now I take this one and connect to M. Then I take Y to N. I did a small feedback now. See that. Now let us make here a small table. I have A, B, and Y. Understand? We make A as 1 and B as 0. What is Y? A is first, initially nothing. Initially all of them are X. Initially all of them are X. No, I don't know anything. And this is X. And this is X. This is don't care. This is don't care. We don't know anything while starting. So I put everywhere X. Now I apply 1, 0. Then what is the output? Understand one thing. Whenever you analyze a circuit, if there's an AND gate, start with 0. Don't start with 1, because when it is 0, you don't worry about other input. Now this is 0. Since both are 0, this becomes 0. You know that? Am I right? Since this is 0, this becomes 1. And this is 1. This becomes 1. And this is already 1 I'm giving. A is 1. And both are 1. This becomes 1. And this becomes 0. Now the 0 comes here. See, now you see that? All the X are gone. Now all the states are known to you. All the inputs, all the outputs are known. There is no X now. Understand? That's the way you analyze a circuit. Now 0, 0, 0, 1, 1, 1, 1, 0, 0, 0. So the output is what now? Y is 0. Y is 0 now. Do you agree this? If you don't agree, let me know. If you don't agree, let me know. That's a trick. Very, very simple logic. Very, very simple logic. And now I do only one change. I don't touch anything. Everything let me like that. I change only this one to 1. But this is already 0. So 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1. So if you make it 1, 1, the output is 0. I don't start with 1, 1. See, I only after this, I'm doing it. That I will discuss later. Okay, now what I do is I convert x to a to 0. I make a to 0. Since a is 0 now, b is 1. A is 0, this becomes 0. So 1, 0, 0. This become 1. And this become 1. 1, 1, 1. This becomes 0. And this 0 goes here. 0, 0, 0, 1. 1, 1, everything. So it become 1. Now I do one small change once again. I change only this to 1 input. This become 1. 1, 0, 0, 1. 1, 1, 1, 1, 0, 0, 1, 0. So the output is. You understand the problem here? You understand the problem here? What's the problem? The table gives you the problem. The problem is this. When I make 1, 1, you cannot tell me the output. If I say A is 1, B is 1, what is the output? You cannot say. You cannot say. If you make this as a box, if you make this as a box, erase everything out. Don't worry about inside. Now we don't need that at all because we have put it in the table. Now, this block, if I give 1, 1, I give you the table. I give you the table. I'm telling you that I'm input is 1, 0. What is the output? If I say 1, 0, or you will say 1, 0 means 0. Fine. If I say 0, 1, oh, 0, 1, 1, you will say. But if I say 1, 1, you are confused. Yeah, could be X. You cannot say that. But what people did was differently. They said that 1, 1 after, see that 1, 1 after 1, 0 means 0. 1, 1 after 0, 1 means 1. Is it correct? I can write a statement like this. I can statement like this. 1, 1 after 1, 0 is 0. 1, 1 after 0, 1 is 1. That means that what you are doing is when I make 1, 0, I'm writing 1 here. Sorry, 0 here. When I'm giving 0, 1, I'm writing 1 here. So I use 1, 0 and 0, 1 to write 0 or 1. But I give 1, 1 to remember or store or memory. You can call anything. Remember, in English we call remember, and in English we call store or memory. So 1, 1 is called store. 1, 0 is called write. Understand? That's why we have after. This is called sequential logic. And you get confused between combinational sequential. That's the reason they change the name here. They change the name to R, S, and Q. A, B, C means combination logic. R, S, Q means, so they've changed the names. R, S, Q. This is called R, S latch. Understand RS latch. Don't forget the table. 1, 0 means 0. 0, 1 means 1. 1, 1 means we write as a Q, N minus 1. N minus 1 means previous. N is present. N minus 1 is previous. That's a way we write it table. So now what we do here is we make this table small. This is called RS latch, which has 2 inputs, 1 output. What we did was, people have had another thing. This is called R and S. They have one more logic. They also given this as R and S. That's a confusion. Forget about it. That's why it's in small letters. They add one more input called C. That's called control. Now they add a special logic. What they have done here is, they made these two, put it AND gate. See here, same AND and NOT, nothing more than that. You don't get confused. See, now you see here, when C is 0, what happens? Whatever could be R and X. Whatever could be R and X. Sorry. So I have 4 inputs, 3 inputs. C, R, S, R, S, and Q. Q is same. Now you see here, when C is 0, what happened now? When C is 0, this is 0, this is 0, this becomes 0, this becomes 1. And both are 1 means what? Q n minus 1. R and S could be anything. When C is 0, the output is no change. I make R as 1, S as 0. See here. I make C as 1. I make C as 1, R as 1, S as 0. Now 1, 0 is 0. 1, 0 is 0. So this become 1. Fine. Now R is 1. Then 1, 1 is 1. This becomes 0. S is 0. So 1, 0 means what? Output is 0. Because I'm using a latch, RS latch. I'm using RS latch. That internal circuit is already there. This is a building block. Now I make R as 0, S as 1. What happened? 1, 1. This become 1. 1, 1. This become 1. And this becomes 0. This is 1, 0. This becomes 0. And this become 1. This become 1. This becomes 0. See that? Now R becomes 0, S become 1. R0, S1 means 1. C is 1. Now you see here, when C is 0, no change. When C is 0, no change. But when C is 1, R10 means 0, 01 means 1. So this is called, this block is called RS flip-flop. When there is a control input, we call flip-flop. When there is no control input, we call RS latch. Both are same. See, 1, 0 is 0. 1, 0 is 0. 0, 1 is 1. 0, 1 is 1. And when there's a control input, that is called RS flip-flop. When there is no control input, that is called RS latch. Now, we have drawn this in a very small block. See that? How we are building the blocks. Maybe go and watch the video, you will understand thoroughly. See that? Nothing. You watch it 1 or 2 times, nothing is great. You draw it, you will do it. It's about 5 minutes work. I have R, S, sorry, R, S, and C. R, S, and C. I have Q. This is called RS flip-flop. People thought, hey, when I give 1, 0, I'm writing 0. 0, 1, I'm writing 1. Why should I have a 2 inputs? If I want to write 0, let me give 0. I want to write 1, let me give 1. Why should I have a 2 pins? So what they did was, they see that they did a beautiful thing. They did a beautiful thing here. They had a C as such. C is there. Now they had an inverter, this they call D. C is a D. They have only 2 inputs now. C, D, and Q. Understand? When C is 0, see when C is 0, what? Q n minus 1, no change. Whatever could be the D, I'm not worried. When C is 1, when D is 0, what happened? Let us see, D is 0. When D is 0 means R become 1, S becomes 0. R become 1, S becomes 0. The output is 0. When D becomes 1 and C is 1, say C is 1, please. Now 1, then this becomes 0, this becomes 1. 0, 1 means 1. So RS latch to RS flip-flop, RS latch to RS flip-flop, to D flip-flop. One important information. This and all we don't use nowadays. Gone. These are all gone. We use only this. The entire FPGA, the entire microprocessor, everywhere we use only this. Nothing is used. These are all gone now. We use only D flip-flop. Then why I've explained this? I want to understand how this came. From the gate, I used the gate, from the gates, I built this one, RS latch. And using RS latch, I built the RS flip-flop. Using RS flip-flop, we built the D flip-flop. That's it. Nothing more than that. So please understand. Now I make this as a block. Now I make this as a block. How we are doing it now, you see that. This is a block. This block is called D flip-flop. Now I erase everything internally. You'll be very surprised. If I tell you some important things, you will be surprised. That's the thing. See that. What is a block? D flip-flop. You have 3 inputs, 2 inputs, D and C and Q. When C is 0, no change. Q n minus 1. When C is 1, this is connected directly. When C is 1, if this is 1, this will go here. If it is 0, 0 will go here. When 1 means connected, when 0 means no connection, the previous one. That remembers. Okay, this is we are using this to build the entire memory. All your memories are built using only D flip-flop. Understand? Oh, FPGA is not ready. FPGA is IC design. Oh, I will tell you what is inside FPGA later. What is inside FPGA, I'll tell you. There is a logic called this like this. No, yes, we don't use inverter. See, if you do the RS flip-flop, if you use RS flip-flop, R, C, and Q. Only R, I use inverter. S goes directly. Yes, we don't use inverter. Please understand. Only C goes here. Understand now?
Sir,
Yeah,
Hello,
ask me.
sir. Then what? Sir, then what is the difference between RSF and D flip flop, sir? If we are not using inverter at this.
No, we don't. We never use anywhere inverter at all. Oh, you want to say that Q bar? Oh, Q bar nobody uses. That is only our college uses. We use only Q. There's nothing called Q bar at all in the industry. That's all. Initial days, about 40 years back, when the flip flops are invented, we used it, but not nowadays. Please. You're worrying about Q bar? I'm not talking
No,
about Q bar at all.
no, sir. That inverter we are giving to the R. Why can't we give to the S? S pin.
No. The problem is I am trying to build a see. You see here, 1-0 means 0. 0-1 means 1. Am I right?
Yes, sir.
Using one input, D input, I'm trying to build. If I give 0 here, it become 1-0. Am I right? If I give 1 here, I have 0-1. For that only I'm using this logic. Because there is one output. Why I should give 2 inputs? That's why people have designed this logic. That does not work. If I give an inverter here, if I give 0 here, both become 0-0, 1-1.
No,
If I
sir.
give 1 here,
Remove
it becomes.
We can remove inverter at R, sir.
Yeah, then what will happen? Tell me. Now understand. You are right. You put an inverter here.
Yeah,
If I give 0 here, what happens? This becomes 0, this becomes 1. 0-1 means 1. If I give 0, I'll give output as a 1. If I write 1 here, the output becomes 0. That is not wrong.
Okay, to
If I
work
give
as a
1,
okay, sir.
that
Got
is
it,
the
sir.
reason
Got
we
it, sir.
put inverter here. Yeah.
Now got it, sir. Thank you.
Oh, I understood your question. Why we put the inverter that? That is because I don't want inverter output. I want, if you give 1, 1 has to be stored. If you give 0, 0 has to be stored. Good thinking. That's a good thing. So FPGA is very good. FPGA have something called you know one thing what FPGA is. I will tell you. I'll give you a small thing here because we have discussed about D flip flop. I have to tell you what is FPGA. FPGA is nothing but I have a small combinational logic. I have another combinational logic. We split a very big problem. We split a very big problem into small combinational logics. Okay, and we call them as a CLB, combinational configurable logic blocks, but nothing but combinational logic. They will be having some 3 inputs and 2 outputs, small. Now, the problem is when I have multiple combinational logics, when this guy gives output, this guy output, this guy output, all are going to input to this guy. There's a problem. This guy could be faster, this guy could be slower, some inputs. So what they have done for that reason, this output does not go to the other logic directly. In between, they added a flip-flop. So D flip-flop. All of them are D flip-flop. This is a logic. I am transferring this logic to this by using a control signal, or also called as a clock. The clock speed. Whenever it becomes positive, the data will go there. That guy will go. That's why they call this the RTL. Register, transfer, logic. In your microprocessor, we have something called assembly language and machine language. Am I right? Like that. Here, we call this as a RTL. Register, transfer, logic. We are transferring the logic to other logic by using a register. So this is combination logic. This is D flip-flop. Even FPGAs, they use only this. In FPGA, we have three rounds. It started with the PLD. Then PLD, there are 2 divisions. One is called SPLD, CPLD. That's called simple PLD, complex PLD. Then came was FPGA. This is full of digital electronics. This is not manufacturing. You can buy your house you can buy a board like a microprocessor board. You can buy a board with FPGA. You can have inputs. You can have outputs from your laptop. You write a Verilog code. You can download to the FPGA. Then this will start working. Like how you are doing now, write a C program and downloading on embedded system programming. In VLSI, we write a code in Verilog, you can do that. Like how you have a site now. We have a site called WalkFee. We have a lot of simulation site. Like we call here a site called EDA Playground. See that EDA Playground, there's a site where you need not have to buy a FPGA board. You can test everything there itself. They have a test bench, everything. So this is a simulation. That's why we do that. Nowadays, we test everything on simulation, then we give it to FPGA. We don't test everything on FPGA. Like how you do it now, I told you now, in a C programming, you go and give it to the WalkP. That, then we will test it out. Understand now? So, VLSI is very simple. Very simple. Only thing is you have to start understanding the moment whatever I'm discussing digital electronics, if you know that you understand, you will see the path is very clear, man. I teach electrical, electronics, digital electronics. Afterwards, you can go to VLSI or we can go to embedded. If you go to microprocessor, then it's embedded. If you go to Verilog, then you go to VLSI. But this is common. What I'm discussing, these are all common for VLSI. That is also built using the same logic what I'm discussing, combinational, tri-state, sequential and tri-state. These three are using built VLSI, built using the microprocessor. Both are, there's no difference. Nowadays, the difference is coming down. And it's very easy also. I think I'm once I've done an embedded advanced course, and now I'm planning for that. Then I'll go for VLSI. Okay. But you don't in the industry, don't try to put your leg on both. That's the thing. That's the same field, easy field. That doesn't mean that you can put the both are skill. You cannot master two skill. That's a problem. So please understand. I built the RS latch. See here, sorry. Using the gates are yes. Sorry, inverter. I forgot the inverter. See, if you try to learn things simple, then you are great, man. If you try to complex everything, then nobody can help. In this 2022, make things simple. Don't try to think anything complicated way. I don't know how to tell you, but that's reality. No, your whole education system, from pre-KG to your engineering, they make everything complex. From algebra to multiplication to division, everything complex. You have been always at tension for 19 years. But the whole technology is very simple. The whole technology today is very simple. You forget everything what you learned in 19 years. You can still pick up. Nothing will happen. So this is called RS latch. From RS latch, we have come out with the RS flip-flop using a control input. This is called asynchronous logic. Why we call asynchronous is whenever RS changes, the Q changes. That's called asynchronous. But here, whenever RS change, output will not change unless C also changes. This is called synchronous logic. RS flip-flop is synchronous logic. From the RS flip-flop, you get into the D flip-flop. D, C, and Q. But even though I explained all these things, and this is very simple. When C is 1, C, D, and Q. When C is 0, whatever may be the Q, D, Q n minus 1, the old one. When C is 1, if D is 0 means Q is 0, 1 means 1. That's it. I think this anybody can remember. This you remember enough. You can coolly forget this. You can coolly forget this. We don't need it all. You will never use that. But you will be using only this. Now, see here, I can also do the other way. See here. C, D, Q. This is called D0, D1, Q0, Q1. See that? Make this block, then you will understand now. If I draw the block, this is C. Now you see here, I added two of them. So now when C is 1, D0 goes to Q0. D1 goes to Q1. They're individual. They are not same. This is called 2-bit D flip-flop. How much? This is single bit, 1 bit. This is 2-bit. Understand? How do I draw this? Very simple. The way in which we draw is you should learn it. The moment you understand the secret, you understand. We put D here, we put C here, we put Q here. We put a just slash 2. That means that the 2 are inside. The 2 are inside, please. Understand now. Nothing else. Now, if I add 4 inside, if we add 4, D0, D1, D2, D3, and all the C are connected. Only one C, not multiple C. There's only one C. When C is 1, all C becomes 1. And this is called 4-bit. So now you understand one important thing. I'll once again draw that whole thing. Then you will understand this whole what it is. You see here, we build a switch. Okay, we go back how the switch came in another electronics topic. How from sand to silicon to P and N material, and then transistor. This is a one solution. How we do that? Then in the transistor, there are 2 types: switch or regulators. Now we are not worried about that. That is fine. The electronics ends there. Switch, digital electronics. From switch, we derived gates. And using these gates, we have derived the combination logic. As simple as that. From the combination logic, we derived adder, a subtractor, mux, demux, encoder, decoder. These are all application of combinational logic. That's right. Now, from here, we built RS latch, then RS flip-flop, then we built D flip-flop. Understand? So using the D flip-flop, we built N bit. Other application we'll discuss on next session. So this is a path. This is the way things has to be. You should have this is called mind map. This is called mind map. Please understand. This mind map has to be very clearly be with you always. How everything has come. If you don't understand this, you should go back here. If you don't understand, go back here. Go back here. Go back here. That's it. So when I go to the N bit D flip-flop, what does it mean? That means I have a D flip-flop which has N inputs and N outputs and one C. Generally, we have a confusion. The C means clock, we think. No, C is actually called control. Control can be used as a clock also, but it's a control. And I've already told you this. If you remember this, don't forget this. If there's a D flip-flop, I have a D, I have a Q, I have a C. Whenever C becomes 1, the D goes to Q. Let us assume that I have a resistor connected to ground. So this is 0 normally because there is no current, it becomes 0. Now I have a switch. I have a switch. Okay. I have 5 volt. When I don't press the switch, this pin is 0 volt. The moment I press the switch, the 5 volt goes here, it becomes 5 volt. So when I press the switch, it becomes 5 volt. Now I connect, I put the switch here. I connect here. So whenever I press the switch, the input will go that thing. I don't want that because I may be pressing a switch for a long time, whatever it is. If that changes, that should not go that. See that normally when I don't press, it is 0 volt. When I press, it becomes 5 volt. There's a edge. You should not draw like this because it takes some time. So always we should draw like this, a small slanting, because this way will take some time. There's no way possible that at same time T, a pin can be 0 volt as well as in 5 volt. That is not possible. That is not possible. That's why normally you see in the books, they draw a small slanting. So now the trick here is I want this gauge to change only now, even though I press the switch for 1 minute. But things should change only now. Afterwards, things should not change. How do I do that? So people did a nice, wonderful thing. What they did was, see here, I have an input. I drawn a small circuit now. I've drawn a very small circuit. If the input is 0, what is output? This is A, this is Y. What is the output? When A is 0, what is Y? When A is 0, what is Y? Quite simple. A is 0 means this is 0, this is 1. So output is 0. Am I right? That's as simple as that. When A is 1, what happened? And this is 1, this becomes 0. The output is 0 once again. Then why this circuit? There's a trick here. Now we have a gate here. This gate will have some delay. That's called propagation delay. This gate have some delay. Now what happened? When A is 0, this guy is 1, this guy is 0, this guy is 1, when A is 0. See here, when A is 0, let's say this is A and this is B. B is 1, A is 0. The output is 0 when A is 0. But, so let us draw like this diagram. When A is 0 and B becomes 1. B is 1. So 1, 0 is Y is 0. Because B is 1, inverter. Now what happened? When I make A as 1, I make A as a 1. A, B, Y. A is 0. So B is 1 and Y is 0. Okay. This is 0. This is 1. This is 0. Now what happened? When I make A as a 0 to 1, Now B will suppose change to 0, but will not happen immediately because of this delay. So what happened? This becomes so much of delay. There's a delay here. See here. This delay called propagation delay. But during the period, both are 1. So Y becomes 1 here for short duration. So that time, the input, so C becomes 1 for short, this when you have this logic. When I have a edge, that time there's a small pulse. So that time D becomes Q. This is called, normally we draw like this. This is called edge triggered flip-flop. You understand what is called level triggered flip-flop and edge triggered flip-flop. If I don't have the circuit, then that is called level triggered. Whenever I press the switch, the level is 5 volt, the input will go to output. That is called level triggered flip-flop. But when I have the circuit in between, when I have this circuit, then that is called edge triggered. It's clear. It's clear between edge triggered and level triggered, because edge triggered is used a lot of places, because whenever there is a edge, the things goes to out. But it's actually not edge. I'm converting a edge to a small level. The level is small here. Even though you press the A for any number of time, this width will be very small. Afterwards, you press, this guy is getting only 0. Nothing will happen. Only during the edge, I will get a pulse. That's why they call this a pulse. Only that time, input will go to the output. Otherwise, it will not go. This is the difference between. Also, there is one more thing here. If I use the inverter here, okay, not here, sorry. Yeah, here also, whatever it is. Here. See here, when I don't press it, when I release it, this becomes 0 to 1. This is called negative edge trigger. Also, if I do like this, see here. See here. Now you see here, when I don't press the switch, this is 0, this becomes 1. Input goes to output. When I press the switch, that time this becomes 1. This becomes 0. This is Qn minus 1. This is called negative level trigger. So there are 4 possibilities in the flip-flop. Understand, there are 4 possibilities. One is called, we draw like this. We draw 4 like this. 1, 2, 3, 4. If I put D, Q, and if I put C, this is called positive level triggered. If we put a small round here before C, D, Q, this is called negative level triggered. Then we have D. If we put a triangle like symbol, arrow like symbol, then this is called positive edge triggered. And if you put the same thing, Q, is called negative . But actually, this is the only what we discuss. This is nothing but I have an inverter outside. That's all. I add an inverter. Then in this case, I add the circuit. This is converting level to edge. Then the other one. So edge to level. Whenever there's an edge comes, it will do a small level. Then I add an inverter. So there are only 4 possibilities. Go on, try to understand. If you don't understand it, let me give me ask a question in what do you call WhatsApp. I'll try to explain. And if you remember this enough. From my point of view, this is sufficient. If you know this, if you understand this, you understand everything. You don't have to remember everything. I've just given you the idea that what are all there, what is meant by edge trigger, what is negative level trigger, what is positive level trigger and all. There's nothing. So do not have to worry about this. You have to worry about only this. Is it clear? I think we have discussed too much today. Please, sorry. Go back and watch the videos. If you have any doubts, you can ask me. But this is all about sequential logic. On next session, we'll discuss about what is the application of sequential logic. Then you will know that. Your VLSI is same. They're all the same. VLSI building block is combination logic, sequential logic, tri-state logic. Only the 3. Nothing but. The tri-state logic make the connections. Sequential logic to transfer. Combination logic to build the logic. That's all. If you know these 3, you will understand VLSI also. But there in microprocessor, we are going to do C. Here we are going to do very long. That's it. So the same CL, SL, and TL are the building blocks of VLSI, nothing more than that. So once we understand the what do you call it? Tri-state logic also, that's it. You can build all computers to VLSI, everything you can build. But it's only your ability to think forward and go ahead. There's nothing more than that. The whole entire digital world is built only these 3. One is, see, there are 2 worlds. One is analog and digital. I'm talking about only digital world. I'm not talking about analog world. Okay, I'm talking about after electronics session, we'll discuss about analog electronics. I have lectures also. I can share with you. But in digital world, 3 gates, and or and not. In digital world, CL, SL, and TL. If you wanted to go into the manufacturing of chips at bottom level, the bottom level you go different. That is a different ball game. But today there the job opportunities are very low in India, as well as you have to do the masters or something. But general VLSI domain, you have to go, or general embedded. This is enough. What I am discussing is enough for the general domains. But in the colleges they discuss totally different ball game, which I don't understand. That's why I don't compare this with your college syllabus. Okay, then let me stop the recording.